Now today we continue with this problems from the CIE past papers of further mathematics, and today I will solve problem 5 from the paper of the winter in 2018. It is a problem about matrix. It is a linear algebra problem. So let's begin. And first, given that lambda is an eigenvalue of matrix A, and E is the corresponding eigenvector, so we have, according to the definition of eigenvector and eigenvector and eigenvalue, we have AE equals to lambda E. And similarly, we have another matrix B, and BE equals to mu E. So they share the same eigenvector. And the first part is this very simple proof. We are asked to show that lambda plus mu is an eigenvalue of matrix A plus B with exactly the same corresponding eigenvector. And so the proof is quite straightforward verification, and I don't even think it is worth stating the proof. Well, we just add these two equalities together, so we get okay, let me try to write it down in more detail. So AE plus BE equals to lambda E plus mu E. And so we have it is very easy, and the proof is done. And however, this very simple conclusion is useful. And so next we are asked to calculate some eigenvector or eigenvalue for some more concrete matrix. And here we are given a matrix like this: 2 minus 1, 1, 0, 2, 0, and 1, 3, 2. Okay. And we are told that the three eigenvectors, and obviously they are linearly independent. It is 1, 2, 1, and 1, 4, minus 1, and 0, 1, 0. Then we are asked to find the corresponding eigenvalues. Well, I even don't think it is. Well, it's not so interesting to do such a calculation. Actually, we just need to we we just pretend to do some calculate, because we only have to say compute just one element, because we know the eigenvectors. By dot product of these two three-dimensional vectors, we got this 2, 0, 1. So the first one is 3. The first coordinate is 3, and then automatically we know that the remaining two coordinates must be 6 and 3. Well, anyway, we have to verify it. Correct, right? Quite obvious. So it is 3 times the original one. So it is the corresponding eigenvalue is 3. Thus it is 3. So the corresponding eigenvalue is 3. And for this, so we just similarly we just verify one of them. It is so the corresponding eigenvalue is 1, and then for the last eigenvector, wow, it is 0. So something like this. Then is the determinant of A 0 or not? It is not 0. It is. Well, this is quite strange. Oh no. Okay, I made a mistake here. So we have to compute the second coordinate. Otherwise, we will give some strange get some strange conclusions. So the first one is 0, and the last one is 0, and the second one is 2. So the corresponding eigenvalue is 2. It's the right eigenvalue. Otherwise, the matrix A will be a singular matrix, but it is not. Okay. And for the next part of this problem, we are told that the matrix B is not given concretely, explicitly, but we are told its eigenvalues, 3 eigenvalues are 4, 5, 1, and the corresponding eigenvectors is something like 1, 2, 1. Let's see, 1, 2, 1, and 1, 4, minus 1, and 0, 1, 0. Okay. Then we are asked to perform a process of diagonalization. So that A plus B to the cube equals to P D, P inverse. Here D should be a diagonal matrix. And okay, now we see that B has exactly the same eigenvectors as A, right? So now we know that A must be equals to we just simply put these three eigenvectors together side by side so that they form a matrix, and then we name it as P. This is P, and then A is something like the diagonal matrix, something like this. Okay, and so B correspondingly it is P, but with a different diagonal matrix, and like this. So we have A plus B squared is something like, say it is P right? And but we could extract the common factor on both sides, and so the sum becomes we just simply add the two diagonal matrices together, and it is 7, 6, 3. So it, well, something like this. So finally we got the answer, because if you multiply this kind of expression by itself 3 times, then you will get well, we just have to compute the third power of this diagonal matrix. So at last we have the final answer. It is equal to P, and 7 to the third power, and 6 to the third power, 3 to the third power, and P inverse. And what is P? And P is just the matrix formed by all the three eigenvectors. So that's all. See you next day. See you tomorrow. Or see you next week.